Managing tables, views, constraints, and sequences. In this nugget, we're going to talk about the basic structure of tables and a little bit about their storage clauses. We'll hit more on storage clauses in our table space nuggets. And then we'll also talk about the constraints that are tied to a table. Think of those as just business rules. For example, you can define whether columns are allowed to be null or not. You can determine whether there's relationships between tables. So we'll look at primary keys, foreign keys, check constraints, and so on. So tables and constraints are both objects. A third type of object is a sequence, and that is just a way of auto-incrementing numbers in a table. Then we'll take a look at views. A view is just a different way that we can look at a table. A table actually contains data, and think of a view as being like a portal into that table. You can see maybe parts of the table, or it might be a different way of looking at a table, but the view object itself doesn't even contain the data. It's actually querying an underlying table. Well, we have two types of views. We have got updatable and non-updatable views. In other words, some views allow you to actually let you perform an insert, update, or delete on it, whereas others don't. So let's talk first about your data. All of your data in the database needs to have a home. Okay, so that home is going to be in a table, and the table itself needs to have a home. It needs to reside somewhere in a table space. So we do have a whole nugget talking about table spaces. I do want to focus here on the table structure. Remember from our intro nugget, we talked about how every table has a name. If we don't fully qualify it, then we assume that it is in our schema. And also each table has a number of columns, at least one column. So here we've got ID, first, last, street, city, and state. I purposely left off zip code because I'm going to show you later how to add a column and also how to drop columns to your table. So in order to add any information to our table, we have to have a structure. So we're going to define the structure first, usually, and then add the data. Now I will show you in a little while how to create the structure and populate it with one statement. So this is the statement used to create our person table. Create table person. Since we didn't fully qualify it, it will go under the schema of the user who's doing this statement. And in parentheses, we have the column names, the column data types, followed by commas. So here you can see my ID is a number. My first, last, street, and city are all varchar 2s with numbers in parentheses. That's just the max length of the data in there. And I made my state be a char because the state is always going to be 2 characters. Now I'd like you to notice that up here my column names are in capital letters, and down here I put them in lowercase, and that's just to show you that it's not case sensitive. Whenever you have database objects or anything that relates to the objects, everything is stored in the data dictionary as uppercase. So when we do a describe on this person table, they will show up as uppercase. Another thing that I'd like you to be aware of is if you're logged in as one user and you want to create an object under someone else's schema and you have those privileges to do that, then you will need to fully qualify it. For example, if I'm logged in as a sysdba and I want to make this person table belong to Scott's schema, then I'll say create table Scott.person. But for right now, let's just be logged in as Scott and create everything locally under his schema. Well, I'm logged in as Scott. See, show user, user Scott. And now I'm going to execute this statement. Now, just for ease of maintenance, it's easier to put all of those columns on their own line. But really, you could have put this whole statement on one line. It would have been fine. Okay, so we execute it. And table created. One of our data dictionary views to look at the tables that we own is called user tables. So select a table name from user tables. And there's our person table. So we want to take a look at that structure. We do a describe on person. So I went ahead and inserted 3 records. Will Wonka, Ned Flanders, and Jolene Schmo. And now let's look at what's in our table. Select star from person. So there we go. Now when you're creating the structure of your table, there's other parameters that you can apply to that. For example, you can specify the storage parameters. And we'll get into some of those, but we'll go into fuller detail in our table space nugget. One thing to observe, though, is that when we inserted our records, we had some things in single quotes like Will, Wonka, all these names, all these strings, and these are going to maintain the case sensitivity. Whereas when you're dealing with object names and column names, those are all going to be in uppercase letters. So right now, our table does not have any constraints applied to it. For example, there's no primary key stating that any records have to be unique. There aren't any check constraints saying, hey, state contains a valid or invalid value. So what I want to show you now is how to create constraints on your tables to enforce these business rules. Okay, to add a primary key to this table, we're going to say alter table person, add constraint, and then we give the constraint name. Here we'll call it PK person. This is a really common naming convention of having PK for primary key, FK for foreign key, and so on, and then the name of the table. Then we specify what kind of constraint it is. It's a primary key. And then in parentheses, we have the column, which is the primary key. When we say something's a primary key, all we're saying is the field has to be populated and you cannot have any repeating values in your record. Okay, let's look at another example. How about creating a table called cities that contains a pair of city and state? Okay, so what would be the primary key here logically? Well, you might say, well, just the city, but what if we've got more than one Springfield? Would it make sense to have a primary key be just the city? Really, it should be the combination of city and state. So when you have a primary key that's made up of more than one column, we call that a compound primary key. So this is the syntax to do that. Now, we could have created the table first and then added the primary key, or we can create the table and the primary key at the same time. So that's what we're going to do here. Let's just do it in one step. So create table cities. We have city, varchar 2, 30 characters max, state, which is char 2 with 2 characters, and then we can specify our constraints. This is what we call an out-of-line constraint, where we define our constraints after we define all of our columns. So once again, we give our constraint a name. We'll call it PK cities, and then we say that it's a primary key, and then in parentheses, the comma-separated list of columns that make up our primary key. Let's go ahead and execute this, and our table was created. So when we do a describe on cities, you'll see that both of these appear as not null. Now, just because this shows up as not null doesn't necessarily mean that those are primary keys. For example, these could be unique constraints. So I'll show you how to dig into the data dictionary to see really what type of constraints we have. There's a data dictionary view called user constraints, and that shows you all of the constraints that you have on your tables, on the tables that you own. Now, if you're the DBA and you want to see all the constraints on the whole system, you would query DBA underscore constraints instead. Okay, so where table name equals cities. So looks like we have a constraint called PK cities, and the constraint type says it's P, which means primary key. If it was a foreign key, it would say R for relational. If it was a check constraint, it would say C, and so on. So we'll cover some more examples here in a moment. Let's take a look at the constraints on the person table. So I did a change there, and I execute it, and we've got a primary key called PK person. The problem, though, is that user constraints doesn't give us information about the exact column that is the constraint. So to grab that information, we need to look into a second data dictionary view called user const columns. If you're the DBA and you want to look at every single table in your whole database, you would say DBA const columns instead. So select column name, position. That position's good for compound primary keys and foreign keys. From user const columns where constraint name equals and then your constraint name. Okay, so looks like for PK cities, city is in the first position, state is in the second position. Let's run this query on our PK person as well. Okay, so ID is our primary key. Instead of issuing two separate queries to grab this information, we could do a subquery. Let's look at this query that's in parentheses down here at the bottom. Select constraint name from user constraints where table name equals cities. This inner query might return more than one record, so that's why we use the word in instead of equals. And so that result set there would be plugged into this outer query, and we run this, and this is our result set. We could also get the same information from doing a join on these tables. We'll talk more about joins a little later. By the way, all these objects that we're creating, all the tables and so on, they're going to automatically be placed in your default table space unless you specify otherwise, and you also have to have special quota privileges on whatever table spaces you write to. Okay, so we didn't have any special table space clauses for our previous statements, so this is going to go in our default table space. What is our default table space? Well, I run select default table space from user underscore users, and so it looks like users is my default table space. Now, if I were logged in as the sysdba, then I could query all the different users by querying the dba underscore users. Okay, now remember a few minutes ago I told you that there's a way to create a table structure and populate it at the same time, and that's the create table as statement. So here I'm creating a table called Colorado person. Since I'm logged in as Scott, this table is going to be under Scott's schema. Basically, this table will have the exact same structure as our person table. My where clause is filtering out the rows, so it's only going to grab the rows in that person table that meet this criteria, where state equals Colorado. So let's look at what's in our Colorado person table. Select star from that table, and we only have Jolene Schmo in there. You know, if you had select privileges on somebody else's table, you could say, you know, create table blah 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 as, and then query somebody else's table. Let's alter this table of ours. Notice we've got ID first, last, street, city, state. We're missing a zip code. I'd also like to add a gender field. So the way we add columns is we say alter table, then the table name. If it's somebody else's table that you're altering and you have privileges to modify their table, then you would fully qualify the table name with the schema and dot in front of it. Okay, so then add, and then the column name, and the data type. Okay, so I'm going to execute this, and it's been modified. So now if we do a describe on person, here we go. Let's also add a gender field. We'll make that char1. So in a moment, we're going to add a constraint saying, hey, it can only be M for male, F for female. Oh, we might have some other genders in there. You never know. Okay, we can give our column a default value. So when we populate a record, and if we leave that column null, it's automatically going to populate it with that value. Okay, describe person. So that's the structure of our table. Another thing to notice is that the order of these is not modifiable. If I want to put marital status somewhere in the middle, no, we can't do that. We'd actually have to recreate the table with the proper order of columns. You can also modify the characteristics of your columns. You say alter table name, modify, then the column name, and what you want to do to it. So here we're going to make the default value be F for female, because, you know, females are 51% of the population. So there we go, table is altered. Now, this default value is not going to show up when we do the describe. I'll show you how to grab that in the data dictionary. If you're logged in as a regular user, you can query user tab columns, and it gives you details on how the columns are defined. So select column name, data default, data type, where table name equals person. And here we go. So shows us that our data default for gender is F and marital status is S. Now the next thing I'm going to show you is an example of a unique constraint. A unique constraint is similar to a primary key in that all the values have to be unique. The only difference is that null values are permitted. Okay, so here I'm going to add a column called username. Okay, so alter table person, add constraint. This is UK person username. UK stands for unique key. And then we specify the type of constraint, which is unique. And then in parentheses, we have a comma-separated list of columns that has to be unique. Okay, so here we go. Table is altered. So let's dig into our data dictionary. Let's look at the column name, data type, data default, whether or not it's nullable from user tab columns where table name equals person. Okay, so you'll see here that the username is nullable. So we're querying our user constraints table and just drilling down to where our table name is person. And here we go. Our constraint is UK person username. That's unique. In all the examples I've been giving you so far, we've been giving our constraints a particular name. You can create a constraint without giving it an explicit name, and if you do that, Oracle's going to give it its own cryptic little name. It will start with sys underscore and then some weird number. So we try not to do that because it's then really hard to dig into the data dictionary and find meaningful data. Do you want to test our business rules? Let's see what's already in our table called person. Okay, we have those same 3 records there. Let's try to add a record violating our primary key rule. Insert into person, we're going to try to enter Homer Simpson with an ID of 5. And it tells us that we have violated our unique constraint. Okay, and it tells us which constraint has been violated. Now it says here primary key. A primary key is a type of unique constraint. Okay, let's modify our query. I'm changing line 2. I'm changing the value 5 to 6. And now re-execute it, and now 1 row has been created. Let's commit our changes. And let's look at our person table. What gender is Homer Simpson? Well, he's been slated as a female, and that's because we had the default value there. Remember how to modify your records? Okay, we're going to update person, set gender equals M, where ID equals 6. So we just gave Homer Simpson a sex change. Hopefully it was successful. And it was. He's now male. Let's also give Homer a username. So update person, set username equals loser, where ID equals 6. And that was updated. Now, I'll show you what happens when we try to violate that unique constraint. See our next statement? We're trying to give a username of loser where ID equals 5. We execute it, and voila, we've violated that unique constraint. Let's add one more type of constraint. We've got gender here, and I'd like to limit those values to be either M or F, and it is going to be case sensitive here. If you want to make it case insensitive, then you would add both the uppercase and lowercase values. So the way we do this is alter table person, add constraint, give it a meaningful constraint name, and then you say the keyword check. After that, you have to have parentheses, and then the column name, so in this case gender, and here we're saying the gender has to be either M or F. So we have a comma-separated list of values. Now, if you were dealing with numerical values, you could say something like, okay, check salary between something and something. Okay, so we go ahead and execute this, and our table has been altered. So here we're attempting to update Homer's gender to be O for other. So let's assume that as a sex change failed. And it tells us, okay, we violated this constraint. So then you could dig into the data dictionary and see which values are allowable. So since that statement failed, he is still male. Now let's talk about foreign constraints. A foreign constraint just lets you define the relationship between 2 different tables. So you'll see here we have our person table, and our person table's got a city and state. We also have our cities table, which also has city and state. And what I'd like to do here is define a relationship to where we can say, okay, if the city and state field is populated here for person, then it must also be a match here in the cities table. Here we say that the person table is a child table and the cities table is a parent table. The reason why we have that child-parent relationship is that person is dependent on the cities table. In other words, if I try to insert a new record or update an existing record in the person table and the city and state does not exist in the cities table, then we'll get an error and it will tell us that we're violating that foreign key. So select star from person. Here's our data, and it looks like we've got 2 people in Denver, Colorado, and another 2 people in Springfield, Illinois. I modified my data a little bit just to make sure that my columns here were present. And here's my cities table. Here I've got Denver, Colorado, and Springfield, Illinois. I'm going to add just one more record in our cities table. I'll add Cheyenne, Wyoming. And now we're going to add the constraint to our child table. So alter table person, add constraint. We give it a meaningful constraint name. I like using the FK for foreign key, then the child table, then the parent table. That's a very commonly used naming convention. And then we specify what type of constraint it is, so it's a foreign key. Now in parentheses, we say the column names, comma-separated list of column names in this child table that's going to be pointing to the parent table. And then we specify what it references. So it references the cities table, and then in parentheses, the columns in our parent table that it's pointing to. So our table has been altered. Great. So if you want to dig into your data dictionary and find out, well, what are your foreign keys, you can query the user constraints table like we did before. We also have a table or view called user cons columns, and that gives us information about the constraint columns. And we need to do an inner join, otherwise we'll end up with that ugly Cartesian product. So where this a.constraint name, A is referencing user constraints and B is referencing user cons columns. Okay, and the table name equals person. So we run this query and we get a list of all the constraints for this table, what type of constraint it is. So P is primary key, we've got unique, here we've got a check constraint, these two R's down here are foreign key. Then the column name is the column on our child table, that is the foreign key, so city and state. And here, the R constraint name column specifies what it's actually pointing to. So it's pointing to PK cities. So once again, we dig into our data dictionary and we find out that our primary key for PK cities is a combination of city and state. So do you see what happens when we try to violate this foreign key? Here I'm updating person so that city equals New York, state equals New York, where ID equals 6. And it's telling me, whoa, hold on a second. I violated the foreign key because that parent key was not found in our cities table. You'll sometimes want to disable your constraints. For example, it's not uncommon to have to load a bunch of data into a table that's got a constraint on it. And what you can do is just say alter table, the table name, disable constraint, and then the constraint name. So the table's now altered. So pretty much it's the structure is there, but it's turned off. Then you could load your data into one table and then into the other table and then turn it back on. And we turn it back on with the enable clause. Be careful with this though. If you try to enable a constraint and there's already data in there that's violating that constraint, you won't be able to enable it again. So then what you would have to do is dig around in your table and find the violating records and fix those and then enable your constraints again. Let's look at our person table again. I've made a little bit of a modification. I've given everyone a meaningful username. And now I'd like to show you the chicken or the egg problem. What if we have another table called users? And in the users table, we want to have a list of the usernames. And we want to have a foreign key pointing from that to our person table and vice versa. Okay, so what are the rules of foreign keys again? Well, remember, your foreign key has to point to either a primary key or a unique constraint. So I've just created a quick little table called users. It's got one column and it has no constraints yet. Now it's tempting to make this username be the primary key, but I'm going to reserve that actually for a auto-incrementing number that I'll describe in just a moment. So let's just make the username a unique constraint. Okay, alter table users, we're adding a constraint called UK users username, and it's unique, and we specify in parentheses a column name that must be unique. And we already had that kind of unique constraint on our person table. So here's our data dictionary that U means unique. Now our goal here is to have a foreign key pointing from one to the other and vice versa. Well, how in the world are we going to do that? How are we going to add any data at all if one is dependent on the other and vice versa? Well, the way we do that is by using deferrable constraints. And then when you type in commit, that's when it actually does the constraint checking. If it's successful, then the commit is successful. If it is not successful, then it rolls everything back to right before your statement. So we're going to alter table users, add constraint, the constraint name, foreign key. Nothing's new here on the first 3 lines, but on line 4, deferrable initially deferred. Deferrable means that we have the ability to turn this on or off, and then it's actually going to perform the check during commit. The initially deferred means that as soon as we create this foreign key, it is initially going to be deferred. The other option is to say initially immediate, which means it's going to be turned on. Even though we can make this deferrable, when we initially define it, if we have any records that are violating the foreign key, we will encounter an error. So we do want to make sure that we have corresponding records in our users table. So let me show you real quickly how to populate that. Okay, we have our insert statement, insert into users, select username from person. 4 rows created. Now we'll go ahead and commit. And we'll add this constraint to the users table as well. Okay. So let's see what happens when I insert a record into my users table. I'm entering J. Johnson. 1 row created. Looks fine. I thought we had a foreign key there. Yes, we do, but it's deferred. We do the same thing, entering a new record into our person table. 1 row created. Now, it's when we perform the commit that it actually does the check. So commit is complete. Let's look at another scenario. Insert into users, B. Smith. That was successful. Now, we don't have a corresponding record in our person table. What happens when we commit? Well, now it's violated, which means that this insert statement up here got rolled back. So that solves your chicken and the egg problem. On to sequences. A sequence is just a database object that stores a number. It's an auto-incrementer. And you use it in conjunction with your tables to create auto-incrementing values. You'll see here that I added a column called ID to my users table. The number 5 in parentheses means that this must be an integer up to 5 digits. So the highest value could be 99,999. We do a describe on our tables, and there we go. We've got username and ID. And then you create sequence, give it a meaningful name. Then you can specify what number you want to start with and how you want to increment it by. It doesn't have to be 1. We could just say create sequence username, blah, blah, blah. And the default behavior is that it starts with 1 and it increments by 1. So our sequence is created. You can query the data dictionary, look at user sequences, and you can find the sequence name, the last number that it was at, and the increment by value. This data dictionary view doesn't mention anything about a table name because this one sequence can be used on multiple tables. Here's our users table right now. Right now the ID isn't set to anything. And the fastest way to populate these with numbers is to update users, set ID equals, and then you specify the sequence name, and there's a function called nextVal, which grabs the next value. So 5 rows have been updated. And here are our values. Another thing you can do with a sequence is query what the current value is. So another function there is curval. Just use the dot operator. You say from dual. Remember, that's our dummy. One thing to be really careful about, and that is when you're defining your sequence, you really want to find out what the highest value is in the table that you're going to be populating with that sequence. Otherwise, you might encounter a situation where that ID already exists. For example, if you already had a value in your username table where the ID was 20, and then your sequence generated a value 20, and that ID column was a primary key, you'd be violating a primary key constraint. So the best way to find the max value of something is to do this. Use the max function. Select max, and then the column name from your table name. Well, the last thing we're going to talk about here are views. A view is also a database object. It's kind of like a table in that it has a structure, but really what's going on is a view doesn't contain any data. It's actually tapping into an underlying table or tables. Why would we want to create a view? Well, if we have a way that we want to query and it uses something complex like some concatenation, well, this right here isn't really that complex, but we could have something a little more involved in this. Once we create that view, then we can select from the view as if it were a regular table. Another reason why we might use views is if there is some sensitive data that we don't want to show to everyone. For example, you might create a view on a person table and grant access to the view but not to the underlying table. So our syntax for creating a view is create a replace view and then the view name. Then in parentheses, we have the column name of the view. So it looks like our view here has only one column. Then our as keyword, and then our select statement. So notice here my select is grabbing the last, we're concatenating a comma, and then concatenating a first. So the combination of all this will be one column in our view from person, and you can even have an order by clause. Okay, let's execute this, and our view is created. The reason why I said or replace in here is that if this view already exists, we're going to clobber the already existing view and replace it with this. In other words, create the view if it doesn't exist, or if it does exist, then replace it with this definition. Okay, I'm going to clobber my already existing view with this select clause. Select last, first, city, state from person, order by last, first. Okay, so we've redefined our view and select star from person view, and now it looks a little different. Let's look again at this definition. This time when we defined it, we didn't have any parentheses with the view columns in there. And the reason why is our select statement is grabbing simple columns and it's not doing any functions. It's not concatenating any columns together. So the view is going to have the exact same columns as the underlying table. Since the columns in this particular view are simple columns, they match up well with the underlying table, we call this an updatable view. In other words, we can use the view to update the underlying table. Like this. I'm updating our person view, set first equals Bart, where last equals Simpson. It's actually updating the underlying table. Now that change isn't permanent until I say commit. Now, digging into the data dictionary, we've got a view called user views, where a regular user can see their own views. If you are logged in as a DBA and you want to see all the views, you would query DBA underscore views. There's a column in there called text, which describes what the view is based on. So select text from user views where view name equals person view. And there's our underlying text. If you want to drop a view, it's very simple. Just say drop view and then the view name. You might hear a lot of people interchangeably using the words view and table, and I've actually been guilty of that. Every time we're querying our data dictionary with those, DBA underscore, user underscore, those are all actually views that are querying underlying complex tables. For example, right now I'm logged in as the sysdba, and I'm going to dig into the DBA views view, and I'm looking at what is really the underlying query when I'm looking at DBA tables. Let's look at this. Boy, there's a lot of stuff there. Woo, going right off the screen. Okay, some really complex stuff here. So do you see how these views can simplify the process of digging out data? So now do you see how views can make your queries go a lot smoother once you have them defined? During this nugget, I've been referencing these tables and views and sequences as being objects. And there's actually a data dictionary view called DBA objects that can be queried by the sysdba. If you're logged in as a regular user, you can see the objects that you own by querying user underscore objects, or you can see all the things that you have access to by querying all underscore objects. But anyway, I'm logged in as sysdba, and let's take a look at all the objects that Scott has. Notice we have our tables in here. We have our sequence. The foreign keys aren't mentioned because they're technically not objects, but the primary key and the unique key, those are all actually showing up as indexes, and we'll talk more about why they're indexes in our index nugget. I hope this has been informative for you, and I'd like to thank you for viewing.